Now let's talk about Amazon SNS. So what if this time you want to send one message and have many different receivers? So you could have a direct integration where, for example, a buying service application could send an email notification, then send a message to a fraud service, send a message to a shipping service, and maybe even send a message into an SQS queue. This is cumbersome because every time you have to add a new receiving service, you need to create and write that integration. Instead, what you may want to do is called a pub sub or publish subscribe. The idea is that the buying service will send a message into an SNS topic, which is publishing a message into a topic. And that topic will have many subscribers, and each of the subscriber will be able to receive that message from the SNS topic and have it for their own. And so this is another type of pattern called the pub sub pattern. So in Amazon SNS, the event producer only sends messages to one specific SNS topic. And the event receivers, or the subscriptions, they want to listen to the SNS topic notifications. And so therefore, each subscriber in your SNS topic will get all the messages sent to the topic, except if you're using a feature to filter messages, and it is possible as well. So how many subscribers can you get per topic? Well, you can have up to 12 million plus subscriptions per topic, so quite a lot. And that number can change over time. I will not update this slide. It's just to give you a overview of how many subscribers you can get. And in your account, you can get up to 100,000 topics, and you can increase that limit as well. And this can change, but again, just to give you an idea of what the limit may be. But you're never tested on limits themselves for SNS. So for SNS, you're going to publish to subscribers, and what can they be? Well, you can directly send emails from SNS. You can send SMS and mobile notifications. You can also send data directly into specified HTTP or HTTPS endpoints. But SNS also has integrations with specific AWS services, such as SQS, to send your message directly into a queue, to Lambda, to have a function do some code after the message is received, or to Kinesis Data Firehose, to send data into, for example, Amazon S3 or Redshift. On top of it, SNS receives data from a lot of AWS services. So they directly send it into SNS. So it can be CloudWatch alarms, auto-scaling group notifications, CloudFormation state changes, budgets, S3 buckets, DMS, Lambda, DynamoDB, RDS event, and so on. So you don't have to remember them. But as soon as there is some sort of notification that happens within AWS, these services will send a notification into a specified SNS topic. Now, SNS, how does that work? To publish a message into SNS, you use the topic publish SDK. And so you create a topic, then you create subscriptions or one or many subscriptions. You publish to the SNS topic, and that's it. All the subscribers will automatically retrieve that message. Or there is something called direct publish for mobile apps SDK. And you need to create a platform application, a platform endpoint, and you publish into the platform endpoint. And it works in terms of subscribers for Google GCM, Apple APNS, or Amazon ADM, which are different ways for your mobile application to receive notifications. In terms of security, Amazon SNS has the same kind of security as SQS, so it has in-flight encryption by default, at-rest encryption using KMS keys, and client-side encryption if your client wants to send some encrypted message into SNS. But again, it's up to your client responsibility to do the encryption and the decryption. In terms of access controls, IAM policies are going to be at the center of security because all the SNS APIs will be regulated by IAM policies. And you can define SNS access policies, which are very similar to S3 bucket policies. And they're very helpful when you want to have cross-account access to SNS topics or to allow other services, such as your S3 events, to write into your SNS topics. So that's it. I hope you liked it, and I will see you in the next lecture.